Alrighty guys, so today we're going to be expanding on what we already know about drawing covalent compounds, and we're going to be actually learning how to draw it a different way so that we can draw bigger structures a little bit more quickly. Okay, but before we do, let's review how to draw the normal stick structure we know how to draw. Okay, so we have the formula CH2, CH2. Since the C's are separated, we know that these two are probably going to be next to each other. We also know that carbon likes to be in the middle of a molecule. And since we have two carbons, what I'm going to do is just put them somewhere in the middle. Alright, we know that the H's can only have one bond. They can only have a single bond with one other molecule. But if you guys notice, the way that this formula is written is CH2, CH2. Okay, so the H's are separated. Now what this means is that the H's are connected to the C's in front of them. Okay? So that means these two H's are going to be connected to this C, and these two H's are going to be connected to this carbon. Okay, so we're just going to draw them kind of in the same proximity as the carbon. Since there's two H's behind this one, we put 2 next to this carbon, and we'll do the same for the other carbon. Okay, now we need to count up the valence electrons so that we know how many lines, how many bonds we can draw. Okay, if you guys look at the periodic table, carbon is the 4th box, so we know that carbon has 4 valence electrons, and so this carbon is going to contribute 4. We know that each H is 1 because it's the 1st box on its row, so since there's 2 of them, it's going to be plus 2. And then this is kind of the exact same thing, so we can just add another 4 and another 2. Okay, we add that up. That means that we can have a total of 12 valence electrons. Okay, we know that every single line is going to be 2 valence electrons. So if we have 6 valence electrons, that means we can have a total of 6 bonds, or we can have some lone pairs in there as well. Alright, so let's do some connecting. We know that the molecule needs to be connected together. It has to be one structure. So we're just going to draw a line between the hydrogens and the carbons because we know that they have to be connected. We're going to do that, and we're going to put one connection for now between the carbons because we know that they all need to be interconnected somehow. Alright, now let's go through the atoms and figure out which ones are happy, which ones are not. Okay, we know that the hydrogens are all happy and ready to go because they can only have one bond because they're so small. So they're good to go. But if you guys notice, the carbons are not happy because if you look at the carbons, how many bonds does it have? How many valence electrons does it have? It has 1, 2, 3 bonds, which means it has 6 valence electrons. That means this carbon has 6, but we know that atoms usually want to have 8. That's what we call the octet rule. Okay, so this one wants 8, and obviously this carbon wants 8 as well. Since they both have 6, that means that we need to get that number 8. Now before we start adding any more lines or lone pairs, let's count how many valence electrons we have left. Okay, first we need to count how many lines we drew. We drew 1, 2, 3, 4, 5 lines. We know that each line is 2 valence electrons. That means if there's 5 lines, we used 10. So we have to subtract 10. That means we have 2 valence electrons left. Okay, and that works out perfectly for us because we said that both these carbons need 2 more because they have 6. And so all we need to do is put a double bond there, and then we used up 2 more, so now we have 0 left over. Okay, so this is going to be the structure for this formula CH2, CH2. Okay, so what we're going to do now is we're going to learn about a different type of structure. But before we do, I just want to make sure we label this. This is what we call the stick structure. Okay, because we draw sticks between the atoms. Okay, unfortunately, as we go forward, we're going to be looking at bigger and bigger structures, and drawing the structures like this is going to become a little bit inconvenient for us. Instead, we're going to learn how to draw something called the skeletal structure, okay? Because it's going to kind of look like a skeleton. So we're going to learn how to draw the skeletal structure. All right, well, what we do in the skeletal structure is, what we have to do is we just need to imagine that the carbons are just like dots, okay? So what we're gonna do is we're gonna go to where the carbons are, okay? We're gonna look at this carbon and we're gonna draw a dot. Okay, we're gonna look at this carbon right here and then we're also going to draw a dot. When we do the skeletal structure, you need to remember we're gonna ignore the H's. And then what we're gonna do is we're gonna turn the C's into dots for now, okay? Okay, so we're gonna ignore the H's. We don't need to draw the H's. We drew the dots for the carbons, and if you notice, there's a double bond in between them. So all we need to do is we just need to connect the dots with a double bond, and that's it. That's gonna be your skeletal structure. So your skeletal structure for this thing right here is basically just these two lines. Okay, so you guys can see we can draw structures that are a lot bigger, a lot more quickly if we use the skeletal structure. Okay, so the rules that you guys need to remember is we're going to ignore the H's. We're going to turn the C's into dots, but when the structures get a little bit bigger, instead of dots, we're just going to turn them into corners. Okay, and I'll show you guys what that means in just a second. Okay, but what we need to do is we need to write all the other atoms that are not C's and H's. Okay, so we're going to draw all other atoms. Okay. Oh, one quick thing. We're going to ignore the H's, but we're just going to ignore a specific type of hydrogens. We're going to ignore the hydrogens that are connected to carbon. Okay, so we're going to ignore the H's that are connected to carbon. Okay? Alright, so let's try drawing a structure that's a little bit more complicated. Alright, so I drew the stick structure for you guys already, so let me just label that real quick. This is the stick structure. Okay, what we're going to do is we're going to practice turning this into the skeletal structure. Okay, so let's go through it. Let's remember our three rules. The three rules are we're going to ignore the H's that are connected to carbon. We're going to turn the carbon into dots or corners. And we're going to draw all the other atoms. Okay, so let's start from left to right. So we have carbon right here. So we're going to turn that carbon into a dot. We're going to ignore the hydrogens next to it. Okay, this carbon is connected to another carbon, so we're going to connect it to another dot. Looks like it's a single bond, so we're just going to draw one line. This second carbon is connected to another carbon right here, so we're going to connect it to another corner. Okay, so we have 1, 2, 3 carbons, so we have 1, 2, 3 corners. If you guys notice, this carbon has a connection to an oxygen, but it's a double bond. So let's do that one first. Since it has a double bond with oxygen, we're just going to draw a double bond with the oxygen. I know that this one's kind of going up, but it doesn't really matter which direction we draw it. This one has a double bonded upwards to the oxygen, but we can draw it downwards as well. Okay, so this carbon right here is connected. We just drew the double bond to the oxygen, but it also has a single bond to another carbon. So we're going to draw another single bond to this carbon. And then lastly, this carbon right here, it has a triple bond to the nitrogen. So what we're going to do is we're going to draw a triple bond to nitrogen. And since nitrogen has H's connected to it, we just need to make sure that we write the H's. Okay? And that's it. This is going to be the skeletal structure for this molecule up here. Okay? So let's just kind of go through and double check, make sure we got everything correct. There is one carbon right here. We'll call this carbon number 1. Okay, so we have a corner right here. This is carbon number 1. We have a second carbon right here. We have a second corner right here. So we'll call that carbon number 2. We have a third carbon right here. And it looks like we have a third corner, so that's where this one is, carbon number 3. And if you notice, carbon number 3 has a double bond to an oxygen, so we just made sure we had a double bond to the oxygen. And then lastly, there's a C over here. That's going to be our fourth carbon, which is right here. And the fourth carbon has a triple bond to a nitrogen, and which is connected to 2 hydrogens. Okay, so that's how we can make sure we drew the right amount of corners. We can count how many carbons we had in our stick structure and make sure our skeletal structure has the exact same number of carbons. Okay. Alright, so hopefully that helps, guys. Good luck on your assignment. Let me know if you guys need any help, but that's going to be it for this week.